afternoon, everyone. Let me start with a scenario that maybe most of you would be familiar with. So let's say you have done a brilliant segmentation project. It has been well appreciated by the client and several appreciative mails have been going through. Now, what after this? Generally what happens is the study somehow sits in the corner of the client's office gathering dust. The new project briefs rarely mentions it, and we generally do not use that huge project in our day-to-day researches. So the question is, how do we make segmentation relevant in everyday research? So what we can do is to check the impact of marketing activities targeted for any particular segment, or what we can do is maybe recruit people belonging to a particular segment and then amongst them test an offer which has been developed for them, or maybe to track segment characteristics like their size or brand performance within these segments. Now, a segmentation study is generally not possible to be repeated after very frequent intervals because of its huge time and cost implications. So what generally the researchers do is they develop some kind of algorithm to classify an independent sample into existing segments. Now, in the pursuit of greater discrimination, what we are currently using are indirect questioning techniques like matchdiff. But the flip side of this is that it leads to more complex algorithms. If we need to classify people into existing segments, the algorithm which needs to be developed in a way becomes more difficult. So some of the issues would be, what would be the choice design? How many choice tasks do we need to ask? What would be the number of attributes that we include in the study? So what we did was we ultimately debated on this and we developed an algorithm which can classify respondents into existing segments in just 2 minutes in real time and by asking only 4 questions. So imagine yourself as a respondent. My question to you would be, what is the most and least important reason for you to have category maybe XYZ when you're on a date? And these would be the 4 need statements that you see. What you need to do is just select your most and least important reason for the first question. Similarly, you'll have 3 other questions where you need to make similar choices. And after the 4th question, you're classified into a segment. And believe me, what you've seen right now is not just an animation on a presentation. This we have actually done for a study where the original study had around 2000 respondents. It had more than 50 attributes and each attribute was repeated 3 times. So in a sense there was about 40 choice tasks and it took around half an hour to administer the choice tasks to a respondent. Now when we had to develop the algorithm, we imposed certain restrictions on ourselves. We decided not to use more than 1/3 of the original attribute list, so which would amount to around 16 attributes. We kept a restriction that no single attribute is to be repeated more than once, and obviously we had to show minimum number of choice tasks. So when we were developing the algorithms, we broke it down into 3 simple steps. One is to select the attributes, next is to classify the respondents, and third is to find a successful way to implement this in the field. So now I'll take you through each step one by one. So what we did was we took the attributes from the original segmentation study. The reason behind this is that we need to ultimately classify the respondents into the existing segments which were generated basis these attributes. So what we did, from all the possible combinations, we generated choice tasks. So what you see in your screen is an example of one such choice task. Now from this choice task, what we did was calculate the probability of the respondent falling into each segment if this was the only choice task that was administered. So if you see on your screen, if this choice task was administered, respondent 1 would be classified into segment 1 with a probability of almost 96%, and respondent 2 would get classified into segment 3 with a probability of almost 80%. And after this, we calculated a prediction accuracy for each choice task. So if you see, the first choice task gives a prediction accuracy of almost 70%. which means that out of 100 respondents, we could classify 70 of them correctly. So how do we know that 70 of them have been classified correctly? All the combinations and all these activities have been done on the sample which was in the original segmentation study. So we already know which segment these people belong to. So basis that we could calculate the prediction accuracy. Now these independent choice tasks give certain prediction accuracy. Now what we decided was that maybe if we select a certain combination of choice tasks, maybe 3 or 4 choice tasks, the prediction accuracy could go up. So in a sense it becomes an optimization problem. So we had an in-house software which iterates, and finally we generated this final set of choice tasks which gave us an overall prediction accuracy of 90%. So whenever a new respondent is administered these 4 choice tasks, basis his or her responses, we can classify him into the existing segments. So if we take this following choice task example, so the respondent chose young to be his most important attribute and indulge to be his least important. Now from the original study, we already know the probability of falling into the existing segments basis his or her most and least important choice. So if you see, if the person selects young as his most important choice, he gets classified into segment 1 with a probability of 50%, similarly in segment 2 with a probability of 30, and into 3 with a probability of 67. Now similarly, probabilities for the least is also computed. Now since young has already been chosen as his most important attribute, when we calculate the probability for the least important, we keep young out of the set of attributes under consideration. So if you see in the slide, we do not have any probabilities under least for young. Now we calculate a joint probability based on his choice. So he had chosen young as his most important and indulge as his least. So his probability of falling into segment 1 would be 50% or 40%, which amounts to around 20%. Now similarly the joint probabilities were computed for segment 2 and segment 3. What we did was ultimately repercentage this total probability so that they add up to 100%. Now remember, all this exercise was done for one choice task. We have 3 more where the total probability for falling into each segment was computed in a similar manner. And if you see, these were the results. So for task 1 we have a probability of around 33, 20, 47. For task 2 we have a probability around 65, 17, 18 and so on. So the total probability of the person falling into segment 1 would be the sum product of, would be the product of all the 4 probabilities in segment 1. So it would be a product of 33, 65, 43 and 49. So the final and then we repercentage them to get the final probability of 97, 2 and 1. So from this we understand that this person has been classified into segment 1. Now in terms of implementation, we have used this algorithm and we have tried to implement this across various platforms, from a simple Excel macro to more complex statistical programming like on R platforms. We have built an online classification tool, a desktop app which is used by our CAPI teams, and we have developed an Android mobile app. So this can actually be sent to respondents on their phone where they can answer, and ultimately we can get the data directly from their phone into which segments they have been classified in. And all this can be done real time. So it's not that the field team goes out, collects the data, and then we have to sit and analyze at the back end and decide which segment the person has gone into. So this has like huge implications for the client. So they have been using this for various activities. So our client has been using them to recruit respondents by segments and test marketing activities and offers within them. They also use this SegIdent classifier to measure the brand performance, the KPIs within segments, and take appropriate measures. So if you see, in segment 1, if you see brand B grows from 11, 14 to 19. So you see there's a increasing trend by month. Whereas if you see for brand C, the brand started with 37% in month 1, in month A, but then ultimately it's declined to 29%. Similarly, within segment 2, brand C declines, but then there is brand D which grows within segment 2. So what we can infer from here is that we can use brand B to target segment 1 and brand D to target segment 2. So there is no need to have maybe one or two brands and target the whole market. We can actually do specific marketing for certain segments. And if I were to conclude, we have an algorithm which is fast, it is easy to implement, and it is versatile. And it only takes 2 minutes of the respondent's time. So the issue of data quality and all that does not arise. And as we say, click, 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 and the respondent is classified. And all your hard work on segmentation, it remains relevant even for regular researchers. Thank you.
Devjyoti, that was very interesting and also a very quick presentation, just like your algorithm. And just to get the ball rolling, I have one question for you. You mentioned that you used about 1/3 of the initial set of attributes. So is there any threshold in terms of the number or proportion of attributes below which the accuracy of your prediction algorithm starts declining?
We have, since when we were developing this tool, we have done several pilots on this, but ultimately it's a trade-off. The more attributes you keep, the more, in a way, the prediction accuracy goes up, but until a point. But then the more attributes you keep, the questionnaire time also increases. So what we have seen, 1/3 is generally a good rule of thumb to take as a proportion of attributes that you include in the study. But again, if you have like around 20 attributes in your segmentation study, then 1/3 would be too less. So then you need to take a call and see what is the optimum number of statements that you take. So it's an iterative process, but 1/3 is generally a good starting point.
Okay.
Karan, hi, Ranjana here from Calcutta, NSC Calcutta. Just to add to what Devjyoti was saying, see, 1/3 is we took 1/3 in that particular study because it had something like 60 odd attributes, and multiple attributes could be used to define various segments. Now there will be cases where the original segments were so clear and so definite that you could even use 1 or 2 attributes to basically identify them. So in those cases, and it is not that for each segment you need equal number of attributes. So in those cases you could decide basically to even go by fewer than 1/3 attributes. So 1/3 is just a starting point, like Devjyoti said, a guiding rule, but need not always be 1/3. It can be lower also.
Okay. Okay. And how does this process differ from the way we used to arrive at segidents earlier when in the BVS for BAT? Is there any major difference?
For BVS, it used to be basically logistic regression. It was a regression-based model. Yeah. And this is basically a choice-based model. So you use the principles of conjoint and choice model to arrive at these. So, like Devjyoti said at the start of his presentation, that the complexity has happened because we moved to things like choice model, math disk, when we capture data, and therefore, even to identify people, the same kind of process has to be followed again. Now, so therefore, when you're developing the SegID, you can't use simple regression and say these are the attributes which actually drive this. You use a choice-based modeling exercise. You generate utilities again. So you generate utilities for each segment again once you have identified the segments. And then you apply the process which Devjyoti just explained. So while, to answer in short, while BVS was a regression-based method of doing SegIDs, this is basically a choice-based method of arriving at SegIDs.
Right. Okay. Thanks a lot. Would anybody have any other questions?
Yeah, this is Ranganathan from Bird, Chennai. My question would be it's related to slide 7, where the entire process has been explained. Actually, the team has chosen to show only one choice task, which has 4 attributes. vis-a-vis, I don't know the total number of attributes which was used in the original study. How many it will be?
In the original study, we had around 50 attributes, but when we developed the algorithm, we had kept around 16. So, in all, there were 4 choice tasks, and each choice task had 4 attributes. So, 16 attributes in all.
Okay. So, out of 16, you are actually choosing only 4 to classify a new respondent or a new member.
No, we are using all 16 to explain the process of classifying. I have shown with just one. So the next choice task would have 4 different attributes, and we would calculate the probability in the same way. So if you see in the bottom table, which has segment 1, 2, 3, and task 1, task 2, task 3, task 4. So the probabilities for task 1 has been calculated basis 4 certain attributes. For task 2, it has been calculated basis 4 other attributes.
Okay. Actually, it is out of 50, you have taken 16.
Yeah.
Right? My doubt will be, is there a heavy compromise here since you are choosing only 16 attributes? Because there will be certain attributes which is not going to be exposed to the respondent at all, which can be a deciding factor whether he is going to be belonging to a particular segment or he could be even an outlier. Because the probability which you are showing in this case is about 13% segment 1, that is before recalibration.
Yeah.
For segment 1 it is 20%, segment 2 is 13%, and segment 3 it is 29%. Which is very well below, the expected ranges, which you are recalibrating to 100%. So, is the actual probability score showing that he is an outlier that is not belonging to any of these segments?
No, see the score, the 20%, 13% and 29% scores are actually not actual probabilities. These give you the hierarchy of which cluster he should belong to. Now to quantify this, we have repercentage this to add up to 100. And to answer your first question, or rather to allay your fears that we are dropping attributes which will help people classify into segments, the thing is that the in-house software that we have, it first selects attributes basis their discrimination across segments. So the attributes which are most discriminated across segments, so which means the deciding attributes which have the maximum contribution into forming segments, those are the ones which are selected.
Ranganath and Ranjana again here, just to add to what Dibjyoti was just talking about, even if you forget this method of arriving at seg IDs, even if you use logistic regression or any method of calculating, arriving at seg IDs which go into a typing tool, the basic principle is that you reduce the number of attributes and you select attributes which are most discriminating and which have the strongest association with the segment per se. That is the idea, because you do not want to do a fresh segmentation. All you want to do is you want to correctly identify a fresh set of people into existing segments. So any typing tool that you develop or any algorithm that you develop for a typing tool works on the basic principle that it cannot have the same set of attributes, because the moment you do that, it is not an efficient design. The idea is just to get a sense of who this person is likely to be. That is the first part. The second is, like Dibjyoti was saying, in this particular case, the attributes are not randomly chosen. The attributes, so you remember Dibjyoti, if you go to the previous slide, we first said that all possible choice tasks are generated using all possible combinations. And then through an iterative process, the ones which give you the most discrimination are chosen by the software. So it's not a random selection process. And attributes are chosen such that they increase their accuracy. So when you check whether these attributes are the ones which are most efficient or which will give us the seg IDs, we check the accuracy. How do we check the accuracy? We basically develop this using the same sample as what we have used for the segmentation. So what you do is when you're developing this and you select these attributes, you check whether by just using these attributes you're able to classify the earlier respondents into the segments in which they originally belonged. So say for example, initially I was classified in segment number 1, right? When I saw something like 30 choice tasks and 50 attributes, I was classified into segment number 1. Now what the software does is, it basically checks for me at which are the 4 choice tasks and which are the attribute combinations that it should take so that I still end up getting classified in segment 1. If I end up getting classified in some other segment by doing this, then the accuracy goes down. And by doing that, we have seen usually the accuracy is to the tune of 90%. And it's not just that when we developed this, we did this with the original sample, and we kept on going back to mining the same data. For 4 markets, we actually recontacted the respondents who were part of the segmentation exercise. We recontacted the respondents. We administered these chosen choice tasks to them, and then we checked whether we were able to classify them into the right segments again or not. And there also we saw just by administering choice tasks, our accuracy was to the tune of 70 to 80%. And if you add certain other layers to it, things like demographics, usage, behavior, which can also be very strong markers, that goes up to more than 90% in most of the cases. So it is not that the attributes are randomly chosen. It is not that we end up basically classifying outliers. That probability is always there. In any model, there will be a certain amount of error. But it is simply that we have found that this model actually reduces error as much as possible. Plus, this was the methodology we checked with, we developed it and we checked it with Sawtooth also, which basically is the leader in this. And they said the method that we have followed is exactly right. This is the process which should be followed. I hope that allays your fears.
Yeah, okay. Thank you. Just one follow-up question to that. So, it so happened that in the study you had arrived at 16 attributes which were the most discriminating.
Yeah.
Or so is this number going to vary for different studies?
Yeah, it will vary for different studies. Ultimately, it will depend on how discriminated your original segments are. So how I would say how mutually disjoint your original segments are, and what is the total number of segment attributes that you have in your segmentation study. So the number of attributes that ultimately you decide to form your choice tasks with, that is going to majorly depend on these 2 things.
Okay, thank you.
Hello, Devjyoti and Ranga, this is Neeraj from AMRB Cairo. Just a very quick question. Once the segmentation exercise is over and you were mentioning that it's quite an iterative process, can you as well share with us an idea of roughly the time that such a process takes?
It takes about a couple of weeks. It depends on how well the segments, how easily the original segments were formed. Usually we find that it can range from somewhere like we have recently done it for one study where it took about a week to develop it. There have been cases in the past where it has taken up to 3 weeks. So it depends actually, like any other say, it depends on how good or bad the data is and how pure and how clear the segments were. So it usually ranges from about 1 to 3 weeks.
And I believe in the process of developing this algorithm, there is as you were mentioning, there is a need to go back to some of the original respondents as well.
No, it's not that we need to go back to the original respondents to test out how correct or how good our algorithm is. We did a pilot where we went back to the original respondents to try and see. So it's not that we need to go back. You already have the data from the original segmentation study basis which we developed the algorithm.
That was just like a pilot, Neeraj, just to build our confidence that what we have done is correct. That was the first time when we were doing it. That is why we did it. Now we don't do this.
Okay, cool. Thank you. Thanks a lot.
Thank you.
Devjyoti, Puneet here from Gurgaon. What has been your experience using these segments or this methodology of defining placing respondents in different segments in a track? tracks have an inbuilt variability that could be coming on account of various non-sampling factors as such. So what has been the experience like, and how have you handled any fluctuation in the segment sizes as such when tracking these on a brand track?
See, so far this has been tried out for BAT in various markets. It has been included in tracks. We haven't really got any data so far on the track. The track data is still, is still coming in. So, wouldn't really be able to give you a very definitive answer on that. We wouldn't really be able to give you a very definitive answer on that right now. Once we are also waiting for the data because it has been, incorporated. Once we get the data and if there are any developments on that basis, the kind of, results we get, we'll definitely let you know. But you're absolutely right because in randomized studies, which tracks are where we are trying to, switch shares and penetration and all that, there can be a whole lot of other factors which can come into play. The usual way to, especially in tracks when you're tracking shares and all, it is the usual way is to look at the data and then see what are the other variables that you can use to increase the, the accuracy. Therefore, what we anyway, regardless of the results which come in, what we anyway do is, like I was saying earlier, is to build in other markers also, which are a little more concrete. So, apart from saying that these attributes will go into it, so say if I know that, a particular age profile is very clearly should belong to this particular segment because they have these kind of needs, we try to build that in also in order to reduce the chances of, data turning out to be unexpected in studies like tracks. But we are yet to see the results so far.
Fine, that would be interesting, as we develop it, because this is a very useful tool that you've developed and has tremendous potential across different tracks and various other studies that are done. So I'm sure a lot of us would be very interested in this.
Yeah, Puneet, this is Joshua here. To add to that, we are using it in tracking two ways. One is actually, for different segments, the brand health markers are different. So let's say in one segment, you have attributes 3, 4, 5 as the key choice drivers.
Yeah.
In another segment, you have 5, 6, 7. So one thing which is being done on the track is we are using this on the fly and asking only the relevant attributes for that segment. So that really cuts down on questionnaire interview length.
Oh.
Subsequently, when we do the segment size, then what Ranjana said, we add the demographics and other things which we cannot do on the fly.
Right.
But there may be some loss of information. We may find that segment 1 we have by chance administered only 90% of them, not all, which is okay. I mean, that doesn't matter. So but you're saving a lot of interview time and questionnaire length by doing it. The second thing is one of the learning, again, it's an important decision to be made. The more statistically robust your original segmentation is, the easier you will find to develop the seg ID and to track it. And the more you kind of use your marketing judgment to, which you sometimes have to do, let's be fair, then that much more difficult it is for a seg ID to replicate those segments. So it's a trade-off you need to make between statistical robustness and the marketing sense of that. The more you move towards the second, the more difficult you will find to track it so accurately.
I agree. So it needs to be done very carefully when we are doing the baseline. The baseline segmentation itself has to be very comprehensive for this to be successfully implemented. Is that correct? Is that a correct understanding, Josh?
Yeah.
This is Raja here. Maybe I have one question. Maybe this may be the last one considering the time availability. This is something for Devjyoti and Ranjana can think about. You have done this shortlisting of some of the attributes based on your programming. Would you think of actually including all the attributes in the original survey itself and conduct the exercise to begin with? The point that you might consider, the reason is that the sheer lapse of time between the first one and the second one is liable to probably cause certain response errors. So from that point of view, if you have included 100% of the attributes in the original segmentation study itself, and then check there subsequently in your analysis, which of these attributes are able to actually classify the respondents into the segment in which they are falling as per the original segmentation exercise. This is something you might like to consider. I mean, if you have a ready answer, you might. Otherwise, you can, study this, and then after that you can get back later as well.
No, see, when we are shortlisting the attributes for the segmentation, for the SegIdent algorithm, that is what we do. We initially start with the entire set of attributes, and then we generate all possible combinations of those attributes to form choice tasks.
From the original study.
From the original segment, from the original list.
In the original study itself, you do that, is what I'm saying.
Yeah.
Okay, just one last this thing. Anybody, people in LMRB and YSs, do you have any questions before we move on, please? Gagan, you might like to check that out.
Yeah, just about to do that.
Sorry, Rastina has a question from Chennai. Can we ask?
Yeah.
Yeah, sure.
Rather, it's a suggestion. I was just wondering, the real-time classification is the attraction of the whole method. Is there anything what you can do beyond research, using this technique beyond research, in terms of even reaching out to the customer, probably in a real, market situation where the customer walks in? Is there a way of using this real-time classification to really see who the customer, where he falls, and then use it for either any kind of marketing activity?
Sure, you can definitely do that. In fact, tracking is one way to use it. The other is you also use this tool for recruitment. So when you use it for recruitment, so say for example, if I take what you were saying, is say if a respondent walks into a shop and you want to know whether that he belongs to segment 1 or segment 4, you can simply do this exercise with them. It can be done on a mobile app. Take 2 minutes of his time and then maybe classify him and then do real-time targeting for him. It's absolutely possible. And it is how it should ideally be used, not just for tracking, I would say.
Have you suggested to the client? I mean, is it possible? Maybe we can develop that further.
Yeah, sure. But we need to remember that the starting point is that there has to be segmentation in place.
Understand.
Yeah.
Can I add something here? This is Saima from Oasis. I think some of the clients are already using it because we have similar algorithms which Nestle uses here for need state and for identification of the right type of mother. We use it for qualitative research. That exercise has done by TNS. So other agencies in other markets and some even in Pakistan market have developed algorithms. We did a similar exercise for a fertilizer company in Pakistan. We developed idents for farmers. So just to identify where they lay on the innovation curve, whether they were early adopters or laggards. So that client has been using that on their database as well. So I think it is very, very usable, and if you sell it to the clients, they actually are quite happy to have it. That client is really very fond of using those, identifying their farmers using those idents, and it has worked very effectively for them.
Good to know that. Thanks, Emma.